Hello dear student, now we will draw different graphs like parabola, hyperbola and ellipse. I will also describe the different features of this graph just like eccentricity, focus, center, directrix, vertices. Let us start. Student, this graph is y square of parabola 4ax. So in this case, if this is the focus, then directrix line will be over here, and this is vertex. And in case of parabola, we know length ratio, just like length ratio is always same. This length to the directrix line. Suppose the directrix line is this, and this length will be same. P, M and F, which is focus. So PF is equal to PM. Therefore PF over PM is equal to 1. Since these lengths are same, therefore our answer is 1. Means PF over PM is the eccentricity, same, which is equal to 1 after cancelling. So now move to other figures. Just like this one. If it is opening in this side, then the equation is y square is equal to minus 4ax, and this is the directrix line. Of course, this is focus, vertex. Okay, we know this is the length of lattice rectum. This is the line which passes through F and meets two other points of perpendicular to the axis of symmetry, is called lattice rectum. Okay, now other figures are, if it is opening upward, parabola is opening, then equation is x square is equal to 4ay. Directrix, vertex and focus, length of lattice rectum. If the parabola is opening downward, just like directrix, this is focus, this is vertex, and this is length of lattice rectum. In this case, equation is x square is equal to minus 4ay. So these are the four figures when their axis of symmetry is x-axis or y-axis. Okay, so maybe it is possible that our axis of symmetry is not the x-axis and y-axis. Maybe the axis of symmetry, just like in this case, the axis of symmetry will be this. Okay, it may be that the parabola lie over here. In this case, the axis of symmetry is this one. It may be possible that our parabola lie in this plane. It is opening just like that. Okay, our axis of symmetry is this one. So depend on the figure. Now different figures of ellipse. in case of ellipse, if here A and A dash is major axis, B and B dash is minor axis, and C is the center. This is the focus. There are two focus of the ellipse whose plural is foci. We called it F1 and this is F2. These are the length of lattice rectum whose plural is latera, length of lattice rectum. There are two directrix in the ellipse. Suppose this point is P and this point is F2, of course. Length ratio PM line, length of PM is always greater than PF2, which means that PF2 over PM is less than 1. Length ratio is called eccentricity. Point to directrix, point to focus. Length ratio is called eccentricity, which is less than 1 in case of ellipse. So equation of ellipse in this case is x square over a square plus y square over b square is equal to 1. Here a is greater than b. Now our ellipse may be just like now B and B dash is major axis, A and A dash is minor axis, and this is center of the ellipse. There are two focus, one focus which is called foci F1 and F2. These are the foci of the ellipse. It is called the line which is perpendicular to the axis of symmetry passing through the focus is called lattice rectum, since there are two lattice rectum whose plural is latera. Okay, so here is the directrix. There are two directrix of the ellipse on the same length, just like maybe it be, you can draw it over here according to the length. Okay, so in this case equation of ellipse is x square over b square plus y square over a square is equal to 1, where b is greater than a. Okay, so now move to what are the possible other figures of the ellipse. It may be just like axis of symmetry will be this one. Okay, these are the axis of symmetry. So it may be just like, if it lies over here, then it means that this is the axis of symmetry of the ellipse. It is the center, it may be another axis of symmetry. Focus perpendicular to the axis, lattice rectum, this is center, center, focus, F1 and F2. What are other possible figures? Other possible figure may be just like axis of symmetry. Now this one. Okay. What are other possible figures of the ellipse? It may be, okay, this is the axis of symmetry. In this case, center is 0, 0. In this case, center is not 0, 0. In this case, center is not 0, 0. Okay. So, if the center is not 0, 0, then x minus a square, in this case, x minus a square plus y minus b square. Here we can write x minus L, x minus m. L and m is the center over a square plus is equal to 1. In this case, if center is not 0, 0. If center is 0, 0, then simply we write x square over a square plus y square over b square is equal to 1. Now, hyperbola. In case of hyperbola, what are the possible figures of the hyperbola? The possible figures for the hyperbola axis of symmetry, directrix and directrix. Okay, let us talk first about this figure. There are two focus, F1 and F2, whose plural is foci. The line perpendicular to the axis of symmetry and passing through the focus is called lattice rectum. This is lattice rectum, length of lattice rectum, whose plural is latera. There are two lines, directrix lines. One line is this one and one line is this directrix line. This is the center of the hyperbola. Okay, so we see that in case of hyperbola, suppose this is the point P and this is M. PF2, this distance PF2 is greater than PM. PF2 is greater than PM in case of hyperbola, which means that PF2 length ratio PM is greater than 1. This length ratio is called eccentricity, is greater than 1. So PF2 and PM. In case of hyperbola, point to focus distance is always greater than point to directrix, point to line. Point to line means point to directrix. So in this case, our x square over a square equation is x square over a square plus y square over b square is equal to 1. And in this case, our equation is y square over y square minus y square over a square minus x square over b square, just like okay. Y square over, it means yes. So this is the equation of hyperbola is equal to 1. So if the center is not lie on the origin, just like it may be just like that. This is the center. Of course, these are two directrix. Center is not lie. So in this case, x minus L over a square minus x minus square minus y minus over b square is equal to 1, where L and M is the centers. So dear students, these are the different figures that I have described in my lectures to understand best about conic sections. Thank you very much.